Well, hey there everybody. Today I'm going to be upgrading the air manifold for my neon bending torches. First I'll show you the current setup I have, explain why it's problematic, and then I'll build a new one. So let's get started. Alright, and this is the current setup. Pretty basic. The blower is an FPZ SLC06 capable of 39 cubic feet per minute, and we got 1-inch PVC coming out. I built this manifold right after I bought the equipment because I wanted to get the torches up and running, and I assumed since this has a 1-inch NPT output on the blower, I thought 1 inch was the correct pipe size, but it turns out it is inadequate because when I flip the lever on the economizer, it causes back pressure to change in the manifold and the other torches will surge and it changes the mix. Also, when you dialing in the mix on the valves, when you change one, it changes the pressure in the manifold again, and it means it changes the pressure on the other torches as well. Originally, I had this set up with only 3 ports, one for each torch, the ribbon, the crossfire, and the hand torch. But that was creating so much back pressure that the pump was overheating, and I quickly decided to open this end up, and therefore I kind of, without a hand torch, I have to kind of swap it at the ribbon burner, and it's a real pain in the ass. So what I need to do is add a relief valve and add more volume to the manifold to create a bit of a buffer to prevent surging the other torches. So we'll go to the hardware store and pick up some supplies. And because no trip to the hardware store is complete without another trip to the hardware store, multiple trips and multiple stores later, I think we have the supplies we need. Also ended up getting a manufacturer recommended pressure relief valve specifically for the FPZ blower. So that should be fantastic. It is a 2-inch NPT, so we're gonna have to do some adapting with our output. I got a mix of steel, pipes, and PVC. So the PVC will be easier to cut and manipulate. And I got the steel as a heat sink to coming right out of the blower, so that'll help keep the motor cool. We got 10 feet of 2-inch PVC, double the inner diameter of the current manifold, and then I got a 2-foot section of 3-inch PVC to act a bit like a buffer tank. So I'll probably be cutting this, at least some, and kind of mock up something and see what we can build. All right, and this is the VLR6 safety relief valve. I wanted to get this specific one because it's designed to be used with the blower. It's from the same manufacturer. I know there are a lot of creative options you can do, kind of do-it-yourself sort of deals, but I wanted to go with this one because it seemed easy and designed for that specific purpose. It's reversible. It can be used for blower or vacuum, depending on how you set it up. And it comes with 2 springs. The weaker spring is in there already, and this green was a stronger spring. It's just a spring-loaded plate, basically. So, you know, the blower will be blowing pressure, and it'll lift that plate as a relief if there's too much back pressure. Adjustable. Comes with the instruction manual. One of the reasons this project was taking me so long to get around to is because I wanted the specific model, and I didn't want to pay full price, so I waited about 3 years for it to come out on eBay. It has a graph of the ranges it uses, how to set up, and stuff like that. So that's what we'll be using for the pressure relief valve. here is what we have for the initial prototype mock-up. Like I said, I wanted to use metal for the first bit to act as kind of a heat sink to draw any excess heat away from the blower. And the 3-inch portion down there is the surge tank. So hopefully all that extra added volume will help prevent the surging. The previous setup I had, like I said, it was a 1-inch PVC there. I used that because it was the same size as the output, and I had mistakenly assumed the previous owner knew what they were doing, and that was my first mistake. They didn't even have a filter. It was just a nylon sock on a pipe with some holes drilled in it. So yikes, hope we didn't damage the blower with any of that particulate matter that could get through there. But I got an actual proper filter on here, the manufacturer's recommended filter for this specific blower. But one thing I did like from the previous setup that before I got it was this PVC coupler. And I like that idea that you could separate out the blower from the manifold if you were to need to disconnect it to maybe do some service or whatever. So I decided to do that same thing again using a cast iron pipe union. So kind of a quick disconnect there, leave the rest of the manifold hooked up to the torches in place, and just be able to pull this whole unit off by itself. So that's what we got going on there. So, but without further ado, I want to test this out, see what it sounds like, and see if that relief valve is doing anything or what. So time for the initial test. All right, I got it all hooked up. Obviously, it's not going to be this long. But I wanted to do some testing before I decided to cut it to fit. And, but yeah, let's get this fired up and see what it sounds like. All right, not too bad. Oh, and hey, we got some air flow coming out of here. Yeah, so that relief valve's working. Got air blowing out of here. Out of here. Out of there, hit the lever. Economizer's going. And more air's coming out of here. So it seems like that's all working properly. Cool, let's try it with fire. Oh, I'm gonna need to adjust the valves. All right, now for the ribbon burner. What's that? Whoa, all right. Plenty of gas there. I'm gonna take a minute to adjust these to the proper heat for working glass. Okay, so I think I got it figured out here. Turns out I had turned the manifold gas pressure down too much, and it was causing the opposite problem of what I had before when it was surging in the gas manifold. I have an adjustable propane regulator, which I think is actually causing me more issues, just adding another variable to the equation, so I'll probably just switch that out for a barbecue grill regulator. I've been tossing around ideas of how to lay out this manifold, be it on the ground, up under here, under there, but I decided I think I want to go with this setup because there is a lot of wasted space up in here that I can use underneath the top of the bending table. Some people may suggest that the blower could cause some resonation, but when it turned on, it's actually quieter than it was when it was sitting on the floor because all this fibrous cardboard acts as a sound deadener, and it kind of traps the sound underneath the tabletop. So we'll have to modify this. I'm going to use this 3-inch piece underneath that ledge right there and cut this down. And because I changed the design layout, I'm back at the hardware store. And I have once again returned victorious with the spoils of war. All right, let's get back to the project. Never said I was a plumber.
All right, well, that was a pain, but it's in there underneath the bending table. And I have one more thing I want to do before I'm done.
And I got some outlets wired here. I wanted to make this mobile like my processing bench because it has the casters on the feet there, and I wanted to be able to plug it in and have outlets available here for my Kitco electric glass cutter and also any like transformer, spark coil, whatever. So that was a goal I had been wanting to do for a long time. And then I also have it running down here to another outlet on the side of the table for accessibility, and a switch which is wired into the air blower, so I'll be able to flick it on and off. But that should be about it. I'll button everything up and we'll do a test. All right, outlet tester said I'm not completely incompetent. I got the Kitco cutter plugged in. Nice. And we'll see what the switch does. Nice. I'm pleased. It's a little loud now because I don't have the hoses hooked up to the torches, but time for that. All right, so I got a new regulator installed, got the torches adjusted, turned the blower on, and everything's looking good. The adjustable regulator, I decided to ditch that because it's a little squirrely on the low end and it was causing me problems because it just adds another variable. So I replaced it with a static pressure regulator. And now when I flip down the economizer lever on the ribbon burner, the other torches don't fluctuate. So long overdue project finally completed. I'm glad I got that done. And I did not glue the main middle section of the manifold pipe, just in case I wanted to take it out and make adjustments or add things later. So let me know what you think in the comments below. Do you like the design, or do you think I could be improved in some way? I'd love to hear your input. I'm always looking for ways to improve my setup. Thanks for watching. Hit subscribe for more neon related videos. We'll see you next time. Ooh, it smells good. I don't know what it smells like, but it smells good.